Inshallah, during this today we will discuss how to make the that tank, including the under plates, the bottom plate arrangement, and how we can include an external like the under plate of the outdoor, how we can include it and make cut for it on those two under plates. Okay, that we will discuss how to make the cans with different dimensions. Okay, and adjust the offset of the lines, and we can calculate it by using SEG. And we will discuss the roof structure, that structure, and how we can include it as external assembly to design. Okay, now let's creating a new project. From here, let's click new, and from here, let's give a name for this project. And from here, select the location of the project. Let's select the desktop location, and from here you find different modules. The tank module, which is related to the storage tank with fixed roof, and click on. Now SEG Software will start creating a project file on the disk, and now the project created. Let's select the equipment node, the left side tree. Here on the left side, find the tree view of the SEG, and when you select the project node, you'll find the information like the number, project name, plant, client, owner, location, all of those. If you would like to fill them, they will use them on the drawing simply. If you would like to reflect on those information in your title, you will need to fill those information and make them interactive with the SEG. Now, setting the node free, you'll be able to fill the design data of this equipment, like the construction code, internal design pressure, design temperature, all of that. And if you would like to import them from external Excel sheet, you can do by importing them directly from an external Excel sheet. Now, let's select the equipment node from. If you would like to change the name of the equipment and modify some information like delivered positions, the position of the equipment, we will need to go to the setting tab. From the setting tab, we will select equipment setting. Okay, when you click on setting, you will get this form, which is the equipment setting tab form. Sorry, you can change the position of the equipment, like making it or tilted or a vertical bezel. The direction of the assembly to make it start from bottom to top. In case of storage tanks, automatically it will be defined as vertical, and the direction will be from bottom to top. Okay, the service of this equipment. Okay, so we define the service of this equipment as let's say a storage tank, for example. Let's name it as a storage tank. Okay, and here's the tag, which is the name of or tag of the equipment. So we can name it as TK-01, for example. And here the serial number for the manufacturer. You can give it serial number based on the your factory. Okay, let's define delivered dimensions. Those values very important in tanks. The SEG will use those values to arrange the plates on the roof and for the shell blades. So
you could use for our project 6 meters and 2 meters. That is the standard here.
Meters? Okay.
6 meters and 2 meters.
1 meter?
2 meters.
2 meters, okay. So here it's 6 meters by 2 meters. Okay, so that's the values of the available blades in your stock. Now, you can change the units of the, you can select between millimeter or inch. In our case, select the millimeter and click on save. You click on save, you receive this message of successfully saved, and the name of the equipment, you can figure that it's changed to TK-00, which is the name that we defined on the number. Now let's add the item on the tank, which annular plates. Okay, if we take a look to the annular plates on the top view, we have 9 segments. Let's calculate them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 segments, okay, of the annular plates. I think they are identical, but here we have 2 blades, that one, small one here, and the small one there, because we have a separate annular plate for the clean outdoor. It's intersect with them, and so the shape of those plates a little bit different. So how to make that by using SEG? So let's discuss first the different types of the annular plates and which is a suitable type you can use it in that case. Okay, here if we select the equipment node, and from the elements tab you will find here API elements. So when you select it, you will find a list of elements. One of them is the annular plate. So let's select the annular plate from here, and when you select this type, you will find 3 different types. The first type, which is the equal annular plate. That shape you can use it in case if you have a typical annular plates and no change will take place on those annular plates. Okay, let's clarify that. Let's assume keep all dimensions as they are, and let's have 9 segments, keep everything as it is, and give you what is the meaning of typical plates. Okay, let's run this model. Here, as you can see, everything will run on behind. As you can see, if you take a look to the prompt of here, you can figure that it's loading, but nothing appears right now, because in that option, you create everything on behind. After that, after finishing, it will be on the final assembly. So if you would like to make a rendering for elements during creation, you may need to go to the setting tab, and from the app setting, you can select the child preview and the parent preview option. That option will give you the ability to make a rendering for elements during creation. Okay, so when you click save, now if you make any update, you will make a rendering for the elements during the update or during the creation. Now, as you can see here, we have 8 pieces, and those 8 pieces are identical, typically identical. Okay, so if you open the bill of material here, you will find on this list the quantity equals 8. You have 8 identical annular plates. Okay, so in that case, the annular plates will be typically in the bill of material. But if you make a small change on one of them, like go inside one of them and make a cut, for example, let's make a cut here, a cut like that, and make an extrude, and make extrude cut, sorry, make this extrude as extrude cut in all directions, and click in all directions like that, through all, like that, and click save. Now we have this cut here on the annular plate. Okay, So when you click Finish Edit and come back to SEG, and from the Edit tab, you will find here an option called Update Parameter. This option will give you the ability to update the parameters of the element and get the masses of each element separately. So when you click on Update Mass and click on the Assembly, SEG in that case will update the items again and come back with the new masses for each element. Okay, but don't forget that when you select the equal annular plate type, which is the first type, that type will not give you an option to update each element separately. And when you open the bill of material, you will find all of them still typically, okay? Because that type, actually, you can use it in case if you have typical items and you will not make any change for each one of them, okay? So for that case that we have, we will not use that type of annular plate in SEG, which is equal annular plates, okay? So because we need to make a cut on some plates. So to update the mass for those plates, we will not use that type, okay? In case if you have a change on some plates, you will not use that type. So we will use the second type, which is annular plate from different pieces, okay? Or annular plate with different pieces and thicknesses. But actually here, all plates have the same thickness, which is 10 millimeters, 10 millimeters, okay? Except the annular plate of the clean outdoor. So we will make them equal. So we will select annular plate from different pieces, and let's define the dimensions of this annular plate. Okay, so from here, let's come back to the drawing. And from here, we need to calculate the outside diameter of the annular plate. Here, we need to define the outside diameter of the annular plate. So we will need to calculate that value from here. We have the that value, which is 6598 plus 39 plus 232 plus 24 plus 29. So that's the outside. Sorry, I think there is something wrong I made.
To the multiply.
Again, please.
In the last step, you didn't extract the value, you just multiply it. You didn't add the value.
So it's 6598 plus. Okay, we can calculate that value. It's here. We have it, so we can accumulate it directly. So it's 659 plus 2762. So that's the outside diameter of the annular plate. So we can take this value as a copy and paste it here. So that's the annular plate outside diameter. And here the annular plate thickness is 10 millimeters. And here the edge length, which is that value 762. So we 762. Okay. And here the material of this annular plate. So we can give it, you can directly type the material text directly from here, like that. Okay, or you can open the material form from here. So let's keep it SA36. And from here, let's define the bottom plate thickness. So in this model, the bottom plate thickness is 6 millimeters. So we can define the thickness of the bottom as 3 millimeters. And for the number of segments we have, as mentioned, we have 9 pieces. Okay. Okay. Now let's calculate the required arc length. We need to calculate the arc length to use it here in this form. So here we have the outside diameter of the annular blade. So we can divide it by 2 and get it with 2 to the power 2. That's the square value for the radius, and we can calculate it with pi and divide this. Sorry, I calculate the area, not the length of the circle. So it's pi with here 18122. So that's the total arc length of the annular plate. We can divide it by 9. So here, if they are equal, so that will be the arc length for each annular plate. So we can take this value here like that and put it here and make a calculation and update the values for each one, and come down here because they are equal, and now click on update. As you can see, all plates now and the last one too will be calculated. Let's remove the this comma. And click on plate. Now, as you can see, plates are equal. Now let's check the angle for the plate. Okay. So that line, okay, can assume it, let's say 20 degrees appear here in this drawing. So we can use with as a 20 degrees, so from or 20 degree 100 sorry 15 degrees, so we can as a 15 degree and click grade. So you can see all start and end angles calculated automatically here. Now let's click on save, okay, and click on reset inventor model to reset all the created parts, and from here click on start assembly to start generating the annular plates again. So after selecting the option of rendering the items during creation, you can see each element during creation, and after that it will be assembled to the final assembly of the tank. Okay, here as you can see, we make the annular plates. Now let's check the option of the mass. If we come back to the bill of material, and figure that we have 9 identical items. Okay, let's do a quick check here by making a modification on one of those, by making a cut here for that one. Click on extrude to make an extrude to all in the 2 sides, and click finish. Now we have one of those plates with a different mass because we have a cut. Now let's come back to edit, and from here click on update parameters, okay, and click on assembly. Now in that case, SEG in that type, SEG will calculate the mass, the new mass for each element, and if SEG find one of those plates with a different mass, automatically it will be separate on the bill of material. Now let's wait seconds until updating the elements. And when we come back again to the bill of material and open the bill of material, as you can see here, we have one of those annular plates not become atypical. So 8 of them are typical and one of them is not typical. And here's the new weight of this item, which is part 9. Okay, so in that case, we need to use, in a case like that, on that model, we have some plates with, we will make a cut on them. So in that case, we will need to select annular plate from different pieces or annular plate from different pieces and thicknesses. Okay, I hope this point become clear now. Now let's remove this this cut here from here. So let's remove this cut and click on finish and click on save. Okay, and select update parameter again and click on assembly. Now during the updating, let's create the bottom plates. If we take a look to the bottom plate, here we have the bottom plate outside diameter, which is 6676 millimeters, and with a 6 millimeter thickness. Okay, and here the arrangement of the plates. Okay, I hope it's close to finish the update. And let's check the bill of material again. Now they become 9 typical items. Okay, now let's add the bottom plate. So from the tank, let's select the elements, and from IB elements, let's select a ranged flat bottom. Okay, so let's select this item and name it as a bottom plates. And from here, let's select this item. And from here, let's define the thickness of the bottom plate as a 6 millimeters. And for the overlap here, the overlap is the overlap between plates, not between the plates and the annular plate. Okay, it's between plates. So we need to check the overlap between that one and that one. So would you mind to inform me about the value here? It's, I think it may
50.
be appear on the other drawing.
50.
50?
50 millimeters. That's the standard. I don't know if here something.
So it's
35. Why? Usually we use 50, but okay, 50. You can use 35.
So let's select it as a 50. And from here, let's define the annular plate diameter, which is that value. So let's copy that value and paste it here. And for the bottom plate material, let's change it like that. And the cut torque tolerance, if you take a look to the image on the right-hand side, and let's make a zoom to make this point clear. Here, when you make a cutting tool like a laser machine or plasma machine or any other tool, or a torch oxyacetylene cutting tool, any tool, you will lose some material here by the cutting. Okay, so if you have a complete plate or half of plate, okay, in case if you will use it in your model, a complete half of plate, like 3 meters, okay, because we are using 6 meters length, if you make it a 3 meters, okay, in that case, the torque cutting tolerance will be equal 0. In the actual case, you will lose some material like 5 millimeters, 10 millimeters. So the half blade will not be 3 millimeters. It will be like, if we say the torque cut tolerance 10 millimeters, so the value will be 6 meters negative minus 10 millimeters. So it will be like that. If we divide it by 2, divided by 2. So that's the value of the half blade. Okay. So if you would like to take this value in your consideration, you will add it. If not, you can add it equal 0. So in that case, let's make it equal 0. Okay. And from here, we can increase the scale of the next form, which is the update blade form. So we can increase this scale a little bit and click on save. And from blade update, you will get this form. This circle scale, you can define it from that form. If you decrease it like that and click on save and open the form, you will figure that the circle with a small scale. And if you increase it to the end, it may be increased outside the scale of your drawing area. So we can, it depends on the resolution in your machine. So let's select, make it on the middle little bit. And when you open, you will get the circle like that. Okay. Now you will find some options here, default options like mid-row, reverse, or center. So let's use some of them and check what is the result after selecting them. Okay, if you select the mid-row here and click on draw blades, you can figure that you will get a mid row here on the annular plate, on the bottom plates, like that. Okay, you will get a row on the middle. So let's remove it and click on reset. Now we will reset the model and click on row plates. As you can see, you will get a startup arrangement. You can modify it after that, but that's the default arrangement based on your selections here. You can figure that the welding line will be on the middle like that, and you have different halves, top half and bottom half of the annular plate. Now let's reset that and select the mid row and select reverse. Okay, when you click like that, you will not have a complete plate on the middle. You have two plates like that, and the other plates will be arranged by that way. Okay, so let's remove the reverse and select reset and select all centered. Okay, and click on draw. In that option, you can figure that with the default values that you will get, you have a half plate here and a complete plate at the top and another complete plate at the top, and all plates centered with the center line of the tank. Let's take an image, print screen, to identify that. Here we have the center line of the tank, so you can figure that all plates will be centered. That one, and that one, and that one. All plates centered with the vessel center line when you select the center, all centered option. Okay. Now let's change the arrangement and make it near to or close to the arrangement. Can you see my screen now?
Yes.
Okay. Now let's come back here to that image. As you can see here, the mid-annular plate is, I think it's greater than 6 meters. Because here, as you can see, that value is greater than 6 meters. So if we try to make that configuration here by selecting the mid row and click on draw to and remove the all centered and reset and click draw again, you can figure that this plate, if you take a look to the information of the plate, so let's take a print screen and put it here and take a look to the information side, which is that one. You can figure that the height of the plate is 2 meters, okay, and the width is 6 meters, okay, and the row active width, that's the active width of the row, is 6,677, okay. So if you would like to modify that value and get the same result here, we need to increase the annular plate or the delivered plate dimensions. So would you like to change that on the equipment setting?
Change it, no problem. Change it. We can use the exact paradigm you showed us.
Okay. So let's come to the equipment again, and from the...
If the contractor would cut it in two, I didn't check it that it was below 6 meters, but no problem.
Okay, as you would like. If you would like to keep it at 6,
it's an example. Go as make it more than 6 to make it as the example.
Okay. So from here we will change that value. Let's make it 7 meters, for example, and click on save. Okay. Now when we come back to the bottom and open the update, let's change the scale a little bit here, as mentioned, and click on save. Now let's open the that form and select the mid row. When you click on update parameter, as you can see here, we have a single plate, okay? But we need to change the other plates on the other side. We have a different configuration here. We have 2 plates here and another 2 plates there and a welding line on the middle. So how to make that in SEG? The first, as you can see, we have 2 rows here. We need to make those rows, merge them, okay? So we need to merge that row with that row, okay? Before merging them, it's mandatory to make this row as a vertical row. So from here, let's select that by right-click on it and make it vertical orientation. And the same for that one, make it vertical, okay? Because those now become a vertical, we can merge them. So from here, let's merge vertical rows. As you can see, now we have a merged rows here. The same thing we will do it here. Before going to the bottom part, let's split the blades here. We have a blade here and another one there. So let's come back to that form, and from here let's split to left. So when you select that, you will be able to split this plate in two pieces. Okay, but as you can see, the value of the width, it's not defined yet. You will need to define it. Okay, so when you select this one, and from the width you can make it as 2 meters and click on update. As you can see, that line is moved because here the origin plate, which is with the orange color, on the right side. So it will be a fixed element. So in that case, when you try to make a split, keep the origin plate on the left side. So let's reset the model again and draw the plates. So let's close this again, sorry, and add the mid row and make the arrangement like that. Make that one vertical, make that one vertical, and merge them. Now let's split to right. So the origin plate with the orange color or the brown color, keep on the left side. Okay, and this the new plate will be on the right side. In that case, when you change this plate, the welding line will be on the middle. So let's try that. From here, because it's an origin plate, the modification will be on the origin plate setting. So here, if we take the append screen and paste it here, so that plate, which we are selecting it right now, so the width of this plate, you can define it from here, from that cell. So let's come back here and define that value to be 2 meters and click on defined. Sorry, 2 meters, not 200 millimeters, 2000, like that. Okay, and from here, let's split this one in two pieces and define this one to be 2 meters, like that. Okay, so by that way, you can arrange plates and split them. So now let's try that again from the beginning and make the steps from the beginning again to make this point clear. Now let's open the update elements after changing the scale, after adjusting the scale. From here, you will open the update plates. And from here, select mid row because we have a mid row here, and click on draw plates. After drawing the plates, you will need to make the orientation of this plate as a vertical and that one is vertical. After that, you can merge them by merging vertical rows. Okay, so, and from here, you will select split right. So you will get a new plate at the right place. And for the origin plate, you will need to define the width of this one to be 2 meters and click defined. From here, split this plate and define the width to be 2 meters. The same thing, we will do it at the bottom, make this origin plate as vertical and that one as vertical. After that, merging them by merging vertical rows. And from here, let's split to right and select the origin plate, define it to be 2 meters. The same here, split this one, select that one, and find the width to be 2 meters. Okay, I hope now it's clear. If you have any questions, we can discuss it.
I think it's clear for what we see. If we have any problem when we try it, we can change it.
Okay.
We can ask you.
Okay. So from here, let's select the longitudinal welding line orientation because that line at 0 degree. So from here, let's define this value to be 0 degree, which is the longitudinal, the welding line orientation, and click on save. Now let's start creating the assembly of those annular plates. A plate by plate will be generated. Okay, I think we need to reset this model because we maybe some error in calculation. As you can see here, we have a missed value on the blade, so we need to restart that model again. So let's click on save, and from here let's reset inventor item and come back and modify the values again. Select mid row and make that one vertical, and merge them. Split to right, define this value to be 2 meters, and that one to be 2 meters. The same we will do it here, vertical, that one to be vertical, and merge the vertical rows. And the orientation at 0, and click on save. Now let's click on start assembly to start creating those plates again. Okay, I think we still have the same issue in this plate. Okay, no problem. Let's complete the that, and after that I will check why this plate not become complete. Okay, now we have the annular plates with the bottom plates like that. Let's add the first can on the for that tank. But as you can see here, if you take a look, you may have some welding lines near to each other. We may need to change the orientation a little bit. I think it's maybe because longitudinal welding line orientation of the annular plate is not the same. We take a look here. So the issue, yes, we have this issue here. This area is a little bit close from the welding line and here. Okay, now let's go to the next item, which is the first can. We have here on that can 1, 2, 3, 4, 5 blades on the first can, and each blade is 5 meters. Okay, I think let's try that. So from here, let's add can. So from elements, let's add a shell blade, and from here name it as a can 1. Okay, and you will find here different types of the shell. For our case, for the tanks, you can use the items from shell from different pieces from that type. Okay, you can select that type, or shell from different pieces and the thicknesses. Okay, so let's select shell from different pieces and define the inside diameter of the tank. So let's come back to the first one and check the side diameter value. We can get it directly from here. That's the inside radius, which is that value. So that's the inside diameter. So we can define the inside diameter here. And the height of the blades, as you can see, it's 2 meters. So let's define it as 2 meters. And the thickness for the first can is 12 millimeters. So that's the thickness. And the gap thickness is 0. And the material, you can type it here. And the number of blades, we have 1, 2, 3, 4, 5 blades. So we have 5 blades. And click on update. Now, as you can see, the first blade length is 4 millimeters. So we can define this value, define those values as mentioned here, the first can is 5 meters. So let's define the first can as 5 meters. The second one, third one, and the last one. And for the last one, which is part 5, it will be calculated automatically. As you can see, it will not equal 5 meters. It will be less than 5 meters. Okay, so let's click on update. And now it's time to change the longitudinal welding line orientation for the first course. Okay, if we, as you can see, for the, I need to know where is the 0 degree. Here is the 0 degree. Okay. So the offset for the first one, or the first longitudinal welding line, we can take it from here. So it's 2 meters and a half. If we come to the setting tab, you will find here an arc length calculator. So if we define the diameter as the tank diameter, which is that value, so let's take that value from here and put it here on the calculator. So that is the diameter of the tank. And here the arc length is 2 meters and a half. So we need to know the angle of this one. So when you click on calculate, so that's the longitudinal welding line orientation for the first can. So we can take a copy from that one, okay, and come back here to SEG and make a paste here for that welding line and recalculate the welding lines orientation in each one. Here, so the first can, that's the start angle, and here the last angle will be calculated, or the end angle will be calculated automatically based on the arc length of the can. Now let's click on save and start creating the first can. Okay. As you can see here, now we have the first can assembled to the bottom and annular plate. And now the next step to add the anchor chairs and the clean out door. Okay. Now for on the first can, we have the anchor chairs and we have the annular plate. Now let's come back again to that view and check the anchor chair dimensions to add it to the model. So let's come back here, and from by selecting the can node, and from elements you will be able to add attachments to the first can. For the supports, you will find the anchor chair. So from here, let's select anchor chair. And when you select it, you will find some different types of anchor chair, like anchor chair as a top plate and stiffening rings, or anchor chair with a top ring. You will not have, you will have a ring, a complete ring at the top here, not a separate plate for each anchor. It's a circular ring. Or you can make an anchor chair for the tanks with a tilted bottom in one side. If you have, in some cases, you may have a tank like that with a tilted bottom from one side like that. So the bottom of the tank will be tilted on one side. So you can use the anchor chair with the third type in that case, which is that one. Anchor chair for a sloped shell at bottom. In our case, let's select anchor chair, which is the first type, and let's define the dimensions of this anchor chair. Here in that anchor chair, we have annular blade. So the annular blade dimensions, or a wear blade, sorry, we have a wear blade. We have 590 with 50 millimeters width. So let's activate the annular blade here, and the height of the annular blade will be like that, and the width is 50 millimeters, and the thickness of the annular blade it's 25. So sorry, where 10 millimeters, 10 millimeters. So from here, let's define 10 millimeters. And if you would like to add a fillet to the ends, you can select the checkbox and define the fillet. So we can make this fillet as 50 millimeters. And from here, the material of the wear plate. Now let's define the dimensions of the top plate of the anchor. If we have another top plate detail, it's 200 millimeters width with 236. So the dimension A, if you take a look to the image on the right side, dimension A is 236, and dimension B equals dimension A, so it will be the same. Okay, and the thickness of the top plate equal 25. Okay, so it will be 25, and the projection, which is dimension C, it's equal 200. So let's keep it as it is, and the edge, you can keep it as it is, 20 millimeters, no problem, because the edge, the sides is straight, so no problem with that value. You can keep it as it is, and the offset, which is dimension F, which is the offset from the end here. So let's check the image. It's 102. Okay, so it's 102, and the diameter, or the hole diameter, is equal 56. So from here it's 56, and no slot hole, so it's equal 0, and the material, keep it 6, for example, and the over thickness, this value we will keep it 0. You can give it a value in case if you have anchor chair over a can plate with a different thickness. Here, for example, let's take a look to the 3D model. In some cases, you may need to change one of those plates with a different thickness. For example, all of those plates with 12 millimeters. But sometimes if you have a clean outdoor, sometimes you may need to change a plate of those, blade thickness, make it greater than that. So you can make it, let's say, as a 20 millimeters. So in case if you change one of those blades to 20 millimeters and you have an anchor chair on that blade, here you will add the difference between the main blade thickness and the current blade thickness. You get my point?
Yes. We can also use it if we have an anchor chair on the wear plate of the
yes, you are right. You are right. Yes.
If the clean outdoor has a wear plate, sometimes you have anchor chairs on it. So we will use that one. Okay.
Yes, you are right. But in that case, don't forget that you will need to create each anchor chair separately.
The ones that are on the clean outdoor. Okay.
Yes.
We won't create a pattern. That's why. Okay.
Yes. Here, the height of the rib is 510. So from here, let's check that value. And the first longitudinal welding line orientation. So we can check the orientation on that view. It's not clear here. It's from here. It's with that offset. So we can open the calculator and define the inside diameter. It was that value. Okay, and the offset is 1,526. So 1,526. And now let's calculate the angle. So that's the longitudinal, the orientation angle of the first anchor chair. Okay, so we can open another calculator. Okay, keep that one. So that's the orientation of the first one. Okay, and from here, the rib spacing. Let's come back to the page number 2. Okay. Here the rib spacing is not clear here, I think.
Let's say 110.
Okay, 110. And from here, the projection at the bottom, which is
60.
the value here, which is 79.
No, I think it's 60. Go and check the detail.
Okay, let's make it 60. And for the rib thickness,
20 millimeters, I think.
20. Okay, and the material 36, for example. Okay, and here, if you would like to add a washer, you can add a circular washer or a rectangular washer. And for the quantity of the anchor chairs, you will add the number of the anchored chairs based on that drawing. So yes, it's 60. You are right, it's 60. Okay, now so let's come back to that view. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 anchored chairs. So let's click on save, and for the assembly, click on start assembly to start creating the anchored chair. Okay, here we have the anchor chair symbol. And if you would like to make any modification, like changing, as you can see here, the annular, the wear blade of the anchor chair is located on the annular blade and no fillet weld here. Okay, but in your model, here if we take a look to that one, it's with an offset from the bottom. Okay, it's with an offset from the bottom, and you have a fillets here. So we can make this modification manually. So when you open the anchor chair like that, you will get the assembly of this one. And for the annular blade, for example, we can make a modification for the offset. We can change this value a little bit for the first one. Let's make it 30 millimeters like that. If it's 30, or I think it's not clear here. It's 50. No, it's 50. So we can change it manually here to be 50 millimeters like that. And if we go inside the wear blade itself, we can make a modification for the fillets by adding those edges here and there. So now we have the annular blades and the wear blade typically with the same in your model. Okay, now let's close this one. And now we have the anchor chair. Now let's add the clean outdoor here. So let's come back here and check the size of this clean outdoor. It's, do you know the size? It's 24 or 26 by 26?
26
36.
by 26, probably. I think 26 by
Okay.
26. 26. Let's say 26.
Okay.
No problem.
Okay, so from here, let's select the can one.
Oh, no, it's 32. It's 32. 32.
So from here, let's select a clean outdoor, and from here, let's add. And from this clean outdoor here, let's select the shape that we would like to include. So let's select shape C or type C, which includes this davit. And from here, select the size. So we have here 8 by 16, 24 by 24, 36 by.
I think that's one.
Okay, so let's select this one, and automatically you will find the dimensions will be defined automatically here. So let's change the material for. Okay, now we need to make some modification on this this clean outdoor, like adding an annular blade. Okay, you will find here an option for adding annular blade. Okay, so from here, let's select this checkbox from here, and let's define the edge length of the annular blade, which is that edge. Let's go to that one, which is that edge. here. So we can make it as a 50, for example. And the annular blade thickness, based on here, it's 29. And the arc length at the flange, so which is, as you can see, let's take a print screen here. Okay. Here, let's consider that we have the flange at, right here. Okay. So if you make an arc from the center of the vessel, and you have an arc here, the arc length at the edge of this one. Okay, so you will need to give SEG the arc length here. So let's assume it, let's say, keep it 3 meters, for example. And from here, select an option for the flat end activation, which is that end. You have a straight line here. We take a zoom like that. We have a line here. It's a straight line. So in that case, you will need to select that option, which is flat end activation. Okay, and from here, arc end at flange. If you would like to make this edge, let's come back here. Let's select the green color. If you would like to make this line as a straight line, okay, you will not select this option. But in case if you would like to make it as a curved arc like that, make it as a curve like that, and give it a radius, you will select this value, which is arc at the end of the flange. Okay, and here the annular blade projection. So it's the annular blade projection is 79, so it's defined it as 79. And here the material of the annular blade will be like that. Now we need to define the projection of the clean outdoor itself and the orientation of the clean outdoor. So if we come back here to that orientation, the longitudinal welding line orientation is located on 135. It will be like that. And here you have the cover thickness and the bolt length. So if you would like to make any modification or make a modification on the standard dimensions, you can select user defined dimensions, that option. And here you will be able to define the standard dimensions manually. And here the cover thickness, you can change it to, let's make it the same, or make it 20, for example. And the flange thickness, make it 20. And the bolt length, you can change it. Let's make it 60 millimeters, for example, and click on Save. Now, when you click on Start Assembly, you will start generating the clean outdoor with annular blade. So here, element by element will be generated and assembled to the final assembly of the clean outdoor. After that, it will be assembled to the final assembly of the tank. Until finishing this assembly, actually, if you would like to make some modifications to suits your project, you can inform us about your modification or requests, and our development team can include it in SEG, and you can use it in your project, inshallah. Like for example, here in that case, for the annular blade, as you can see, the annular blade here, which available in the clean outdoor, we take a look from the top view. it's here, this line goes directly to the center line of the vessel. It's not perpendicular to that line. Okay, but in your model, we take a look with that one here. That line is perpendicular to that one. This angle is 90 degrees. Okay. But in SEG, this line, if we let's take an image, print screen and put it here. Sorry, we can complete over that. So that line goes directly to the center of the vessel. So it's tilted a little bit, not perpendicular. So if you would like, or it's important for you to make it like that, perpendicular, you can make a request and our development team can modify something like that and give you a new release, include this modification. That's regarding to this point. Okay, now as you can see here, we have this annular blade intersect with two of annular blades here, that one and that one. So now let's check the option of modifying the annular blades manually. Now let's go to inside this annular blade here and make a sketch on this one and print the annular blade lines here, okay, and make an offset with 35 millimeters or 50 millimeters, okay, to make a cut inside this annular blade. We need to make a cut on this annular blade to suit the make a cut with all sides. Sorry. Okay, so now we make a cut on this annular blade like that. Okay, and we can do the same on the second annular blade. So from here, let's make a sketch. And by printing the lines of the annular blade, we have that line, that one. So we can make an offset, which is the overlap, and define it with 50 millimeters, be like that. And make extrude cut through all and the all sides, two sides, and click on finish. Okay, as you can see here, now we have this cut on the annular blades like that. Okay, now let's update this item to get the accurate weight for those items. Now let's come back to the annular blade, and from Edit tab, let's select Update Parameter button, and from here let's click on Start Assembly to start creating the or updating the mass of the annular blade. Okay, now let's come back to the bill of material here. As you can see here for the annular blade, you will find the 3 rows for the annular blade. You will have 7 identical annular plates, okay, and you have a separate annular, identical 2 annular blades, which they have cut here, that one and that one, okay, and you have another annular blade for the clean outdoor. As you can see here, it's related to the clean outdoor. Okay, so this annular blade, it's related to the clean outdoor, and you have 2 another identical plates and 7 identical plates. Okay, so by that way you will get correct bill of material. Okay, now we have this clean outdoor. As you can see here, the dimensions, the standard dimensions of the clean outdoor, which is 36 by 48. Okay, it will give you that size by that way. As you can see, we have a clash here between the anchor chair weir plate with the manhole weir plate. So we could make a little bit modification on the anchor chair by decreasing the width of the annular plate. It's 50 millimeters, so we can make it 350, for example, and click on save. Now let's click on start assembly to update the anchor chair weir plate dimensions. Okay, I think we still have a closed area here. Okay, no problem, but you should take care about that during modeling. And you have here on the 3D model, everything I think is so clear. Okay, now let's go to the second step, which is creating the second can. So let's go to the second can. Okay, for the second can, we have the same arrangement, okay, but with a different longitudinal welding line orientation. So here we have the 0 degree. Okay, I think the longitudinal welding line orientation for the first can, we defined it in a wrong way, I think. So we need to check that again. So from the setting, let's open the arc lens and take the diameter here. And here the arc lens is 1.5. It will be like that. And so the arc lens, that's the value. So that's the orientation of the first longitudinal welding line. So let's come back to the can and change the first longitudinal welding line orientation. And click on save. And for the anchor chair, let's check it again. Sorry. That's the location of the anchor chair. Sorry. That's the location of the anchor chair. So let's come back to the anchor chair here and modify the orientation of the first anchor chair. And for the can, so let's come back here. The first can here, we have 360. So the offset here is not.
Let me check it.
We need that value or that value.
I'll give you give me.
We could assume it 140.
Assumed. Let's say it's
130, for example. Okay. So
1200. Let's say 1200.
Okay. So from here, 1200 and click like that. So we will 360 minus that value. So that will be the first longitudinal welding line orientation. So let's come back to the can.
No, I think it's 17.23. It's
again,
right.
Please.
It's not the minus. It's the 17.323. The first longitudinal.
I think yes, it's in the positive direction. So you are right. You are right. It's in the positive direction. So we can change that value. I think the same for the anchor chair.
No, the anchor chair is correct. It's in the minus. We use the other one.
We start creating this one, which is on 0.60. So I think we need to calculate it again. Sorry.
The first longitudinal line is at 1,250. It said it on the upper of the drawing.
So it should be like that. So the anchor chair value will be like that. Now let's add another can. So from elements, let's select the equipment node, and from elements, let's add another can as a can 2. And you can select select the part same as to make CAN2 looks like CAN1 to avoid repeating the data entry again. So the same type will be selected, the inside diameter, length, everything. So you will need to change some parameters like the thickness. Here for the second CAN, thickness is 8 millimeters. So we may need to change the thickness to be 8. And the number of segments, it's the same. And the offset of the first longitudinal welding line orientation, let's calculate it. So it's 1,200 plus 2,500. So from here, let's open the calculator. Sorry, let's open the calculator. Let's add this value. 3,700, and here that's the longitudinal welding line orientation. Let's put it here and click on update. Now click on save. Now that's the second CAN. And for the third CAN, it's the same orientation of the first CAN, but with different thickness. So from here, let's add CAN3, CAN3. Make it looks like CAN1. Okay. The only thing we will change, which is the thickness, keep the orientation as it is. They click on update. I think we change the orientation here. We make it 17.
Yes, I think so.
So I didn't click on save. Sorry.
17.323.
Okay. 17.323.
Yes.
Update and save. And for that one, 17.323, and click on update and save. And for that one, we already changed it. Okay, so we change the third CAN, and for the fourth CAN, it looks like the third CAN, second CAN. So from here, let's add CAN4, CAN4. It looks like CAN2, so let's select this checkbox, and from here, select CAN2, and click on add. And we will need to change the thickness only, 6 millimeters, and click on update, and click save. With the last CAN, CAN5, CAN5, it looks like CAN3, and click on save. So it's 6 millimeters. Everything is okay. So I think now all CANs. Okay, now let's start the assembly. Don't forget that we make a change on the first CAN orientation. So the first CAN will be updated. After that, the anchor chair will be updated. Finally, the second, third, fourth, and fifth CAN will be generated.
Is there a way, even manually, to place the anchors in the anchor chairs?
I don't get your point.
We don't have in the anchor chairs. We don't have the anchors. We have only the chair.
Okay, I get your point. Okay, I will show you how to generate the anchor bolt and add it to the model. After finishing this
Okay, no
one,
problem.
I will show you.
Of course. Just had a question.
That's the last CAN, which is CAN 5, the last one. Okay, here we have the all CAS symbol like that. Okay, now let's add an anchor bolt to the anchor chair. Okay, let's come back to the second drawing here. We have this anchor bolt, and here the dimensions of this anchor bolt, it's M52. And here we have the total length and the thread length in each side. So from SEG, you have a separate solution here called SEG Helper, which is that one. When you open it, you will get, for the first time, you will get a separate library here on the Autodesk Inventor items. You will find a folder called SEG items template. When you open it, you will find some accessories like base plates, eye bolts, washers, circular washers, rectangular washers. And for the bolts and the nuts, you will find those types of bolts, crossbeam shackles, and flanges, platform clips, hot rolled sections, standard hot rolled sections, tie rods, and wires for tightening or transportation or lifting. Now let's select bolt and nuts, and from here select the stud bolt. As mentioned here on this drawing, we have a stud bolt. It's a straight rod. So let's select this one and click on create. And now you have this one here. And from the iLogic form, and if you don't have the iLogic form, you can open it from the View tab. Okay, and from user interface, you can select the iLogic, and the form will appear. You will find some tabs here. You will need to go to the Forms tab and select, click on the stud bolt data. Okay, now you will have the ISO or UNC. In our case, we have the ISO, and from here we have a size of for 55. So you select the size as 55. Okay. And here you will get this dialog, this message which inform you the nut spacing need to be increased. So you will select OK. And now you will need to change the length of the anchor. So the total length of the anchor, let's calculate the total length, 143 plus 1303 plus.
I think it's 160.95. It's the right, the left one.
Okay. Okay. So, oh, okay. Sorry, I didn't get it. Okay. So that value. So here that's the total length. Okay. And the spacing here between the nuts, we can make it 1,500.
Let's say
which
1,000.
is spacing. Okay. Let's keep it like that, 1,500. And here's the material, and this value, which is a part number, which will appear on the bill of material, we can, or the balloon, we can keep it right now like that. Now we have this anchor bolt. Now let's save it. When you try to save it from here, you will not be able to save it from Autodesk Inventor. You will need to come back to SEG, and from the Assembly tab, you will find a button here called Save Active Document. Okay, when you click on it and come back to Autodesk Inventor, you will get this form. So from here, you can create a new folder called External Items. Okay, it's for you. This folder, it's something for you to be able to add the external items inside it. So let's add this one, anchor stud bolt. Okay. By the same way, let's add a rectangular or circular washer. It's here, I think it's a rectangular washer. Yeah. And we have another. So let's add the nut first. So from here, let's select a nut and click on create. And from here, select the size of the nut to be 52. Sorry. And here's the material of the nut. And click save from SEG by saving active document, and come back here and anchor nut. Okay, and finally let's add a washer. So from here, let's select the accessories, and from the washer, let's select washer. And from here, let's select the washer length. It's 150 by 140. And the thickness is 10 millimeters. And the hole diameter is
56.
let's say 56. Okay, and that's the material. And save this part from SEG by save active document, and come back here as anchor washer. Okay, now let's create a new assembly. So from here, let's select the N and create an empty assembly, a new assembly, to add the anchor items inside it. So from here, let's select the external items, add the anchor chair, and be sure that you add it as place grounded at origin. And now let's add the washer. We have two washers here. Okay. Okay. No locations for the washer, but we can assume the values. So we can assume the value from here to there to be, let's say, 200 millimeters, for example.
Okay.
Oh, no, one, let's make it
50.
100 only. And for the second one, let's make it, let's say 40, 50, like that. And make those faces on the same direction. Now let's add the the nuts. So from here we have two nuts at the top and two nuts, one at the top and one at the bottom. So we have two nuts here, and let's assemble those first. Okay, so we have this nut here and that one over that one. And on that side, we have a nut here. And another nut on the other side. And now we have this anchor assembly. Now, as mentioned, if you try to save it, you will not be able unless you come back to SEG and click on active document, save active document to get this tool. Now you can save it, anchor stud bolt assembly, and save it. Now, after saving it, you can add it to the main assembly of the anchor chair. So if you open the anchor chair from the tree here you have the pattern of the anchor. You can open it from here, or directly you can open it from the assembly. You will find the anchor chair assembly. You can open it like that. And you can add this stud bolt to the assembly of the anchor from here, or you can add it to the final assembly of the tank and the batternette. So it's up to you. Okay, so right now let's add it here. So let's select this hole. From here, select that one. And now we need to adjust the blade. So from here, you can select angle. We can make this one take the same orientation of this one, make it 0. So here, as you can see, we adjust the orientation of the anchor chair with the anchor chair with the anchor bolt like that. Now we need, for example, if you would like to add those items to SEG bill of material, okay, we add them to the final assembly. But now they will not be clear, or they will not be mentioned in SEG bill of material. So how to add those items to SEG bill of material? Okay, there is a way to add that by adding those external items to bill of material from here by selecting extra bill of material. So by clicking on this, you will be able to select the tank node, and from here you can select this item to add it to some of the sub-assemblies. Here you will need to add this anchor bolt to the anchor chair. So you can select the anchor chair from here and give it an item number if you would like to add an item number. And actually we have 8 anchor bolts. It's anchor bolt. And from here it's M52 with a length equals 1,606. Take that copy, and that's the length. Okay, and the material we can we can calculate the material. So let's open the anchor from here. We already have it, so we can open the anchor directly from here. Get the material. Here we have the material, so we can define the material and get the weight. So from here we can, from the physical, we can get the weight, which is 29 kilograms. So, and the part name is anchor bolt, and the part number we can give it any number, no problem, and click on save. Now when you click save and close the form, this item will appear here on the bill of material. So when you export that bill of material to your drawing, this item will appear. Let's add the nut, for example. The same thing we will do. Let's select the equipment tag, and from here select the anchor chair, and we have 32 nuts, and the description is anchor nut. Okay, and the technical characteristics, it's nut M52, and the material we can get it from here. So let's close this and open the nut and give the material of the nut from here. Put it there, and for the weight, let's get the weight of this nut. Let's open it here, and the part name is a nut, and give it any number here, no problem, and click on save. Now, by that way, as you can see, when you close this form, you will get this item appear in SEG bill of material. Okay, by the same way we can do the washer. Okay.
Okay.
So here we have this assembly of the tank with the anchors like that. And if you would like to exclude this assembly of the anchor from the drawing, you can remove it from the anchor assembly. If you would like to make it disappear on the drawings, and you can include it separately. So by that way, you can include it in the model. And if you would like to remove it, just remove it from here, and you can go ahead with the other items. Okay, now we would like to add a stiffening ring as a channel at the top. Okay, if we take a look here on this one, we have a channel here, and we have another angle here on that level. So let's check how to add an angle on the third can, because this angle located on the third can. So let's select the third can from here, and from elements and from external attachments, let's select the external stiffening. Okay, so from here you can add a stiffening ring with a different configuration, like I beam or H beam, U channel, different shapes or a ring. So from here, let's add stiffening ring 1. Stiffening ring 1, like that. And from here, let's select an equal angle. And from here, select the size of the angle. So if we have a detail for that, it's equal angle 100 by 100 by 10. So from here, let's select 100 by 100 by 10, and here's the material and the location. It will be located at the middle of the can. So let's click the assembly and check the direction of this angle, and we could flip the direction of this angle based on the configurations that we would like to get. Okay, so let's take a section here, half section, like that, and let's take a look to the angle. As you can see here, this angle is not located on the right direction. It's flipped. So from here you can select weld edge. Okay, so when you click on save, so that means it will be welded to the tank from the edge. It will be like that, and we need to flip the direction of this angle. It's not on that direction, it's to the bottom, so we need to select the flip angle and click on it simply. Okay, we could try to change it manually. Let's open this one. Okay, we may need to check that. Okay, no problem. Let's close this one and click on click save and set inventor item. And click on start assembly again. I think we may modify the orientation of this one manually after assemble it, because the direction is not correct. So we need to flip the direction of this one manually. So from here, let's open this simply. And from here, we could make that as be like that and accept. And for that one, let's make it be like that. Keep it flush, sorry. Let's come back. Okay, let me check that and give you the feedback about the flipping it, because it's not comes in a correct way. If we would like to make it, to modify it manually right now, we could remove the constraints of this one from here right now, and we can assemble it manually. So from here, let's make it located to be like that. Okay, and move it up here. And that's the third can. So from here, let's do the third can. And we could hide this and define the location. So the location could be 1 meter from here to there. And make this can appears again. Now we have this angle with the flipped direction like that. Okay, now let's check the adding channel. So from here, let's select external attachment, and from here, let's select stiffening ring. Okay, and click on add. And from here, it's a channel, so we can select UBN and check the size of the UBN here. It's UBN 240. Okay, and here's the material and the location at 2 meters. Click on save and start the assembly. Okay, as you can see, it's located from the center of the flange of this angle. So we need to decrease the location with 25 millimeters. So from here, we can decrease this value. And click start assembly. To modify the location of this one. Okay, now let's remove the section first. And now let's add the roof of this tank, the steel structure that we made it by the iLogic. Okay, so let's get that one and put it inside the project. Okay, and from here, let's open the assembly of this flat roof structure. Open the assembly from here. And here, that's the inside diameter. So from the main form, you will find the option button. This option, which is auto activate, you can keep it, and in that case, the code automatically will calculate the required lateral beams. Okay, so let's close this form and add or define the inside diameter of the tank.
Please do it again. I was typing a new invitation and I lost the last step. If you could
no problem. I just changed the diameter from
no, how you opened it. I didn't see how you opened it.
Okay. I just take a copy from the source file and put it inside the project.
Okay.
So that's the project. So here I paste this folder, which I send it to you. I shared it with you.
Yes,
After that, from here I open the assembly, go inside the this folder, which is flat roof structure, and open the assembly of the tank. And from the main form here, I kept the options as they are, didn't make any change. And when you add the inside diameter of the tank from here and click enter, automatically the items will be activated for the lateral beams. They will be activated automatically based on the inside diameter of the tank. Okay, now we have the beams activated based on that. Now we need to adjust the spacing between between the main IBE. We have main IBEs here, and we need to adjust the location, the spacing between them, and the size, the connection with the tank. So from here, you have a form for the main beam data. When you open it, you will find here a list for the sizes of the IBE available. So here, let's select 300, which is mentioned on the drawing. So when you change the size, so let's come back here. And if we take a look from that side, for example, let's change the size to be 500, for example. As you can see, the size of this beam will be changed automatically, and the connections to this beam, which is the rib and this plate, everything will be changed based on the change here. Okay, and here's the clearance between the end and the inside diameter of the tank. Here you have a gap, okay, between the beam and the inside diameter of the tank. This gap, which is the clearance, okay, which is that area here between the tank and the beam, which is defined in 10 millimeters. You can change that value to be, for example, 5 millimeters, like that. Okay, so this gap will be 5 millimeters. Okay, and the spacing between beams, you can control the spacing between the main beams. Here in this drawing, if we take a look to that one, here we have between the center lines, we have 1 meter. Okay, so the spacing between them is 1 meter. So let's come back here. So the spacing between those beams here is 1 meter. So you can increase this value. So for example, let's make it 2 meters. As you can see, automatically the spacing will change, and the dimensions of as you can see, the dimension of the lateral beams here will be changed based on that. So let's come back and make it back again with 1 meter. As you can see, all lateral beams will be changed based on your change of the spacing. Okay, and here the dimensions of the main beam support angle. So if we take a look here to this support angle here that's the information of this support angle. Here that's the length of this support angle. So you make it, let's say, 30 millimeters. So you can increase the length of this one. Okay, and here the bolt size. So you can increase the bolt size, let's say 30 millimeters, for example. So the value of this one will need to change the length of the bolt because the size is increased, as you can see here. And here the hole diameter, okay, it should be greater than the bolt size. So let's make it again 20. Okay, and the hole diameter automatically will be changed to 24. So if you would like to decrease it, you can decrease it. So let's keep it as 24. And here the bolt length. Okay. And here the bolt spacing. So you can increase the bolt spacing like that. Okay, and let's make that 100. And here the main beam support plate, which is that plate, which is that plate. So you can change the dimensions of this plate. So let's make it 300 millimeters like that, or 380 like that. Okay, you can change the width of this plate. So the total width of this plate, you can make 50, for example, that. And the thickness, 50, for example, as you can see, change. And the bolt offset, it's 60, so let's make it 100, for example. The offset from the end. Okay, and here the spacing between bolts, like that. Here, let's make everything come back again. And here, finally, let's make the size back IBE 300. As you can see, everything related to this one will be changed based on it. The rib at the inside, all the blades here, everything will be changed based on that. Now, after modifying the main beam information, it's the step to identify the intermediate beam data, okay, which is that beam size. Okay, so here's the size of the IBE, which is at the default here, it's 200, it's IBE 200. So if we increase it, for example, if you take a look here, increase this value to 270, for example. So the size of the blades will be changed based on that. Okay, and all lateral beams size will change based on that modification. Okay, so as you can see, okay, now as you can see, after changing the size of the lateral and intermediate beams, automatically the blades changed. And from here, the rib thickness, which is inside, we take a section here. So let's take a half section from here to there. We have a rib, stiffening rib inside this beam. So the thickness of this stiffening rib, as default, is 16. So for example, if you would like to change it to 50, automatically it will change on the model. And let's remove this half section. And for the end blade, which is that one, here the thickness of this end blade, if we change it for 50 millimeters, so those blades thickness will be changed to 50. Okay, as you can see, the nut goes outside the length of the bolt, and here the width of the blade, so you can control the width of this blade. So we could make it, let's say, 200. It will be like that. And the bolt size, you can change the bolt size. As you can see, the code will inform you that when you will use a 10 millimeters bolt, the whole diameter should be not more than 14 millimeters. Okay, so we will accept, and automatically here the diameter of the bolt of the hole will be 14. Automatically change it to be 14. Okay, and here the length. So let's change it again to 16. So the whole diameter will be minimum 16, so we can make it 18. And here's the bolt length. You can control the bolt length of this one. And the vertical spacing, so you can increase the spacing between the bolts like that. So that's a vertical spacing. And the horizontal spacing between the bolts on that side and the bolts on the other side, between here and there. Okay, so if we increase this value to 100 millimeters like that, so you can increase the spacing between bolts. Okay, that's for that part. And here the beam offset from the tank center line. We take a look to this image here, or to this drawing. As you can see, you have a spacing between the first line here to the vessel center line. Okay, so here on this model, to define this spacing, okay, it's defined here. So when you change it, let's say for 50 millimeters, for example, automatically all the lateral beams will be changed. Okay, and you will get that spacing by that way. So let's increase it like that. So that's the first row location from the tank center line. You can see everything will be updated. And here the spacing between that one and that one, which is a constant value, which is that value, the spacing. After that, you can add the spacing. Okay, so the first location, after that, you can add the spacing. So they could be a different values. Okay, for example, here you could make the spacing between that one and that one. Let's make it 750, for example. So as you can see here, a new lateral beam will appear here after decreasing the spacing. A new lateral beam will appear here because we have an empty space here, and based on the calculation, we will need a new one here. So if we, as you can see, we have 4 beams here, 4 lateral beams, but if we increase it again to 1 1,200 again, like that. As you can see here, we have 3 lateral beams. Okay.
Okay.
And the number appears here automatically. Okay. Now, to define the materials, you can define the blade materials. You have the beam material, the blade material. Let's make it 36. The bolt material and the nut material. You can define all the materials from 1-4. And for the mid lateral beams, here, where they those lateral beams, those beams here, sorry, a beam like that. Okay, you can change the blade length, the support angle length, so which is that one. So if we make this angle length is 300, for example, it will be like that. Okay, and here the length of the blade. That blade length, width, and thickness. Let's change, make the lateral size IBE 200 again, which is that one. And now let's activate the intermediate supports channels. Okay, as you can see here, we have an intermediate beams, those beams here, and we need to increase the number of those plates. So from here, from cross UBN beam, we can increase the number of supports inside this one. So from here, that's the offset for the first line, which is 700. We take a look from here. That's the first offset for the first line, which is that one. And here the spacing between them. Sorry, from here that's the first line, and here the spacing. And from here we can define the required number of beams. So for the first piece, we can increase the number up to 5, and for the second one, here we can make them 4, so they will be like that. And for the last one, we can make them 2. So I think this one goes outside the tank, so we can make it 1 again. And here we have this roof of the tank adjusted like that. Now let's save this one. And if you open the drawing of the bill of material for this roof, let's open the bill of material of this roof, which is this one. You will get a bill of material for each element. We can merge the identical elements by selecting this, and from here select the status, material, mass, and make arrangement based on the status or the material as you would like, and click on save. Now you will have the bolts at the beginning. That's the required number of bolts with each size and length. Okay, and here the IBE is required in your project, and the equal angles, and here the nuts in your project, and here all blades in your project. Okay, now if you would like to calculate the required number of beams that you will get it from your stock to start fabricating this. Here we have a tool called one-dimensional nesting tool. Okay, this tool will give you the ability to make that calculation. Here you will define the stock length of the material that you have in your workshop. Let's find it as 12 meters. And here the cut gap, you can put it as 10 millimeters, 5 millimeters. It's based on your workshop capabilities. And from here, we will move this column before the quantity here. And let's take a copy from those values, if we take a print screen to increase this one and take a close look here, we would like to calculate how much number of beams we will need to buy to fabricate those items. We need 6 items with that length, 4 items with that length, and another 4 items with that length. So how much items we will need to buy to fabricate those IBEs. So from here, let's open the one-dimensional listing tool and make a best. We can take a copy from them here, and we may need to export them in Excel, but if it's not pasted, okay, it's pasted here. Now, when you click on calculate, as you can see here, totally we'll need 5 beams with 12 meters length, and they will be cutted by that configuration. We have 2 beams will be cutted with that arrangement, 7 meters and 3 meters, and the remaining value will be like that. So let's export this Excel sheet to the desktop. IBE 200, and click on save, and let's close this one, and let's come back here. Okay, let's convert those 2 numbers. Okay, so here totally you will need 5 beams with 12 meters length. 2 of them will be cutted with that value, 1 piece with 7 meters and 877, and another piece with that value, and 1 beam will be cutted with that arrangement. Okay, 1 piece with that value, another piece with that value, another piece with that value, like that, and the remaining value will be 29. Another piece will be cutted with that arrangement, and another piece will be cutted with that. Okay, so totally you will have 5 beams from IBE with 12 meters length. Okay, so let's save this, and let's come back again to the bill of material. Let's remove the length before the quantity. Okay, and from here, let's take a copy from the equal angles. Take copy, and let's open that one. And now we don't have pieces more than 6 meters, so we can keep 6 meters as they are. And by clicking on that one, we have 1, 2, 3, 4, 5, 6, 7. Okay, so we can delete those because they are typical. Okay, and make that value was 14. And for that one, let's delete this one and make that 4. And click on calculate. Now, as you can see, we need 1 beam with 6 meters length, and we will get a remaining value with around 3 meters. Okay, so that's the arrangement of the beams that we will cut it from a stock length 6 meters. Okay, we will need 1 part only. Okay, now for the UBN, we have a UBN with 44 items with 1 meter 0.70. So let's check that. Click paste and click on calculate. Now we need totally 9 parts of UBN 100. Okay, and 8 of them will be cut with that arrangement, and 1 of them will be cut with that arrangement. Okay, I hope that become helpful for you by using that technique of getting the bill of material with the required length, and by using the one-dimensional listing calculator to calculate the required number of stock lenses or stock beams in your workshop. Okay. Now we have this model. After generating it and assembling it, we can add it to the final assembly of the bezel. So from here, let's select the place component, and from here, let's go to flat pattern, and from here, select the flat pattern structure. As you can see here, one important thing, we have some extra elements. It's appearing here, but it's not appearing here. because here we activating the suppressed item level of detail. Okay, if you activate the master level of detail, actually you can figure that you have some other items. Okay, they should be included. So here on the tank assembly, we will need to add a new level of detail here, which is roof detail. Okay, and from here we will activate that one, and in the same case we will activate the level of detail of suppressed item in the roof assembly. And now when you click update and save, now you will have the roof without extra items. Now let's assemble this with the tank. So from here, let's make that one to be like that, and make that face aligned with that face. Okay, so that's the roof structure of the tank will be like that. And for the orientation, you can get the mid plan here and control the orientation of that one. You can make it like that. Okay. So by that way, we generate the tank, okay, with the clean outdoor with the bottom plates and annular plate, and we learn how to make a cut on the annular plate and which type of annular plate actually we used to get the correct values of masses based on that, and the type of the shell plates that we used in modeling, and how we calculate the offset of the welding lines by using the arc length calculator, which is that tool, which getting it from the setting, which is arc length calculator, by using this one to calculate the longitudinal welding line orientation for the cans and for the anchored shears, and adding the stiffening rings on the tank. And actually I will share the issues that we received here on this stiffening angle with our development team to check how we can modify it and make a new release updated with that. Here we, after creating it, we make the edit the assembly manually, but I will discuss that with the development team to be sure that everything is accurate. And we made the roof structure by the iLogic model that we did. And if it's confirmed from your side, I need your checking over that.
Okay, we will use this week, and we will come back with some feedback.
To proceed accordingly with the fabrication drawings of that one, to make it with iLogic, so you will not spend a long time modifying it. Automatically, okay. It will be generated. You will make some little changes, like adding some dimensions or missing balloons or something.
Okay.
Okay. I think today we discussed many things, and I think we spent 2 hours and a half, maybe.
Okay.
I think it's enough today for you and for me, and
okay.
We still have the remaining time of the 10 hours of the training course, so we can complete another case and adding some nozzles to this tank. After that, proceed with the fabrication drawings of the tank and how we can make a nesting for the blades. And I could give you a quick let's say presentation about the nesting. Here for the annular blades, for example, you can make a nesting for that assembly. For example, here we have those blades, so we can make a quick study for the nesting. Here, that's the blade. Here we have SA36 with thickness 10 millimeters. And here the nesting tool will we'll get the items, and from here, let's define the blade dimensions. Here, that's the blade. Let's say 7 meters by 2 meters, as we discussed. Okay, and here you can define the gap. Let's keep it as it is, and from create nest tool, create a nesting study. We could create a nesting. I think the dimensions of the annular plates here, we have the annular plates arranged like that, and we could make some modifications on the annular plates itself to make it make sense
More
before
efficient.